right, let's see. Week 11, and I am ready to share the screen. Let's see. Chrome launch meeting looks good. And just go over here to presentation mode. And then pull up my slide notes. One more time. All right, you should be ready to go. All right, so welcome to week 11 of Information Security and Systems Management. I am prepared to go through the topic of audits and observability. So thank you for joining, those of you that are dialed in, and if you're watching later, of course, downloading the lecture and watching it later, hello and welcome to you as well. So this is the penultimate lecture. Next week is the last one. And this topic, I've got a lot of slides this week because this is one of the condensed lectures where I took the 14-week course and turned it into a 12-week. So we will probably, well, anyway, there's lots of material to go through, so let's get started. All right, let me just double check that I'm using the right mic. Looks good, and audio is fine. All right, cool. So in software development, change management is the practice of reviewing and approving software builds and deployments, as well as configuration changes for various network, server, and storage infrastructure. Change control is an important component of the SDLC, the software development lifecycle, or sometimes referred to as the system development lifecycle. There is typically a CAB, a CAB, which stands for Change Advisory Board, or similar body, which meets to review and approve major project initiatives and changes, and information security plays a key approver role at all stages, including project inception, development, and testing. It should not, where possible, be seen as a road bump in the last stage of a release from UAT, user acceptance testing, environments into production environments. This lecture is also the best time to introduce the concept of who's watching the watchers. If information security are the watchers, who's auditing the work that the information security team performs, or the systems administrator, or the systems administrators and other privileged account users? We will touch on the idea of how to create some process and tooling which enables periodic audit of the information security team itself. Audit. An information examination, an independent examination of any entity, whether profit-oriented or not, irrespective of its size or legal form. InfoSec is understandably focused on making sure that there is an audit trail, that permission requests are documented, and that they're approved and verifiable. When we speak of an information security audit, we're talking about the review of procedures and processes, both in their documented form and in their practice. The word audit derives from the Latin word audire, which means to hear. The term is most frequently applied to audits of financial information, but information security audits are the systematic evaluation of a company's information systems with an eye towards whether it conforms with the stated policies and controls. So what kinds of security audits are we going to look at? I want to take a look at 4. Risk assessments, vulnerability assessments, penetration tests, and compliance audits. There are many different types of security audits. Some audits are specifically designed to make sure your organization is legally compliant. If there is, for example, a regulatory oversight and jurisdiction over your industry or sector, like financial services. Other audits focus on recognizing potential vulnerabilities in your IT infrastructure. Risk assessments are used to help identify, estimate, and prioritize risk for organizations. Security audits are a way to evaluate your company against specific security criteria. While this might not be the case for specific businesses, security audits can help with compliance issues in heavily regulated industries. Shown here is the infamous Tacoma Narrows Bridge, which collapsed 4 months and 7 days after it was dedicated on November 7th, 1940. It oscillated in the wind and was amplified due to a resonant harmonic frequency of the design and the materials that the bridge was constructed from. The engineering failure became a textbook case and revolutionized the designs and procedures for building suspension bridges. If you've ever seen the film of this, you can see the bridge is, flowing almost like a wave of concrete and metal. And the wind wasn't blowing very strong either. And so anyway, this was just, I thought a reasonably fun and interesting image to include when thinking about risk assessments and, how it applies to not just IT, but also to material science and engineering in general. All right, so vulnerability assessments. Vulnerability assessments are meant to uncover flaws in your security procedures, your design, implementation, or internal controls. It identifies weaknesses that could be triggered or exploited to cause a security breach. During a vulnerability test, your IT team or an outside expert will examine and determine which system flaws are in danger of being exploited. They might run specific software to scan for vulnerabilities. They can test from inside the network or use approved remote access to determine what needs to be corrected to meet security standards. Shown here, a typical artist rendering of David versus Goliath. Oftentimes, it's a very small flaw that is taken advantage of and exploited in order to breach an organization. Penetration test. When you have a penetration test, you're essentially hiring an expert who's acting as a hacker in an attempt to breach your security systems. Penetration testers use the latest hacking methods to expose weak points in cloud technology. Also, weak points in mobile platforms. And we'll be talking about mobile a bit this week. And of course, weak points in operating systems. Internal and external penetration tests can be performed, and with privileged or unprivileged access, depending on the type of threats that an organization is likely to face. So a privileged penetration test means that you would potentially be giving your penetration tester typical third-party vendor remote access to some of your infrastructure. And in unprivileged access, you would give them nothing. They would come in with no advantage, no knowledge of the inside, no access, and they can, of course, request accounts to various systems and see if those account approvals, and those account requests go through and try to gain access, just like anyone doing reconnaissance as an actual bad actor might do as well. Let's see. And last but not least, the compliance audit. So to comply with certain regulations, you oftentimes need to have a third-party assessor, and you have to figure out which framework you're going to be measured against. It could be ISO 27001, it could be NIST CSF, could be a SOC 2 Type 2 audit and a compliance audit. And of course, there's lots of specific frameworks that are used in retail, finance, healthcare, and of course, government. Government, for example, you could need to be FedRAMP compliant, which has lots of requirements and takes at least $1 to $2 million to reach FedRAMP compliance for most organizations, due to the need to change policies and procedures, and of course hire people to perform the assessment and to put you into a FedRAMP. I think they have low, medium, and high status. A compliance audit is a comprehensive review of an organization's adherence to regulatory guidelines. Audit reports evaluate the strength and thoroughness of compliance preparations, security policies, user access controls, and risk management procedures over the course of a compliance audit. While compliance and audit are like two sides of the same coins, they play very different roles. While audit may monitor what the organization is doing and find deficiencies in a company's policies, processes, and procedures, it may not actually identify whether the organization has actually complied with its legal obligations. So therefore, a compliance audit is more targeted and has very specific outcomes and measures. So let's talk a little bit about two words here that I've mentioned, I think, a little bit: observability and monitoring. Observability is, in my mind, complementary to monitoring, and it addresses some different aspects. I think of observability as being concerned with surfacing system behaviors whereas traditional monitoring is more failure-centric. So observability is going to help provide an understanding of why a system is not working, and monitoring is going to be satisfied with knowing whether the system is working. So the volume, velocity, and variety of the data that is being collected is fundamentally unmanageable by humans these days, right? For monitoring and infrastructure, even for just a few, 100 servers. For this reason, machine learning and artificial intelligence have been applied to the problem of logging events and metrics, key performance indicators, KPIs. Learning algorithms can understand the past health of your services and applications to predict what's going to happen in the future. Shown here is an image of an electron cloud chamber showing traces of atomic and subatomic particles. So let's talk about observability for a moment. Logging, of course, is concerned with events. Tracing is concerned with requests, which are a specific type of event. And then metrics, of course, are used to aggregate various patterns that one finds in the logs and events. Traditional monitoring tools are inadequate for modern infrastructure comprised of auto-scaling and ephemeral components. In control theory, observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. In information security, observability can be created by ensuring that logging is enabled, that requests are being traced, and that metrics are being aggregated and analyzed. So let's break some of these down. Observability for logging. Event logging is an immutable record of discrete events that happened over time, or at least it should be immutable. You don't want someone to be able to change it and hide their tracks of what they did afterwards. So we've discussed monitoring previously, of course, and I've offered the opinion that security events are just a subset of all logging events. There are, of course, discrete security logs for Windows systems and Unix systems that ought to contain a high degree of signal to noise. But oftentimes, the defaults that are configured for Windows security events, for example, are extremely verbose and not terribly informative. This is why deduplication and aggregation of logs is an important aspect to observability. We want to know that all events are being logged and that all events can be observed if needed, drilling down to the raw event logs, for example. But in the day-to-day practice of observability, we want to be shielded from the noise and the clutter of all of this data. Let's see, when we're talking about intrusion detection systems, here's an example of an IDS log. So this shows there was an SNMP trap, simple networking messaging protocol, over the UDP, over UDP actually. And it looks like it was recorded when? On March 6th, and at a particular time, so 8:14, from an IP address 192.168.1.167 over port 1052 towards another address, which was 172.30.128.27 on port 162. And so the UDP entry here shows that there was a time to live on the request, and what else? There was a bit of a trap, basically. SNMP trap was called. And attempted information leak, of course, is what was logged in this intrusion detection system. And so in some cases, you have intrusion prevention as well. IPS and IDS go hand in hand quite often, and it may well have blocked this request. But you want to know that it happened, and then you want, of course, someone to go and investigate. Why did the IP address 192.168.1.167 actually attempt to make this request? Let's see. Another type of observability for logging would be firewall logs, right? So this one is from March 6, 2006. It was an example that I found on the internet, nothing related to me or companies that I've worked in, for example. This was at 8:14 a.m. and the rule block Windows file sharing, right? And so it blocked 192.168.1.54 using NetBIOS over port 139. So this is a TCP rule, and it's basically blocking the request. It was an inbound TCP connection, and it looks like, I think Kent is maybe the name of the server, and it resolves as 172.30.128.27. The remote address, again, was a system that is on the inside, right? It's using RFC 1918 private IP address of 192.168.1.54. And let's see, at 9:04 a.m., which would be a little bit later, it looks like the firewall configuration was updated. Oh, wait, no, this is the date a couple of days earlier. So there's two log lines here in this example. The one from March 3rd is from 9:04 in the morning. When the firewall configuration was updated, it has 398 rules, and the firewall configuration had that many rules after, of course, the update performed. And you want to be, of course, having backups of your firewall rules, perhaps daily or more than once a day, so that you know what changed and when, in case the bad guys do actually get in and make changes and open up holes in your firewall for them to have remote access. These are certainly some of the things that bad guys do, and that's why we need observability and logging and monitoring of these configs and when they change. Another example of observability for logging would be an antivirus software log. Again, taken off the internet from a system named Kent in 2006. It looks like on 3/3, on March 3rd, the antivirus system was shut down on Kent, and the user, user K, I guess, and the system log events. And then it was started up on the 4th at 9:33 in the morning, and you can actually see that a few seconds later the definitions files were downloaded and updated. Antivirus definitions files use signature-based detection, and so you constantly need to have an antivirus software that is receiving new definitions and signatures for the different viruses and malware that are known to the company that you're using. I don't think this one makes a reference as to what antivirus solution it is. It may well have been Symantec or something like that. And here's an example of a Windows security event. And so you can see it's a little bit chatty, almost doesn't really fit on the screen here, but you can see that the computer is called Kent, right? And the client domain is listed, and the username is user K. This is also what, from 3/6/2006. Looks like the audit log was cleared in this event. And so the Windows event ID listed here is 517. And so if you're going to have aggregated monitoring on a SIEM, right, a security information and event management for the InfoSec team, for the SOC, right, for the Security Operations Center, they're going to want to know about someone clearing, the audit log and deleting all of the entries. Hopefully there's a backup. Hopefully this wasn't a malicious event, but you can see it was successful. And in this case, you would be searching in Splunk or something, right, for event ID 517 and looking at how often that happens and seeing if there's a pattern. For example, if Kent and other systems are having their event logs cleared after an infection or some type of breach event, for example. Let's see, logging architecture. This is another aspect that we should think about and talk about for a minute. Reliable log delivery, transmission confidentiality, and transmission integrity. So many early implementations used connectionless, unreliable user datagram protocol, right, UDP, to transfer logs between hosts. UDP provides no assurance that log entries are received successfully or in the correct sequence. And so as the security of logs has become a greater concern, several implementations of syslog, which is one of those early security logging implementations, have been created that place a greater emphasis on security. Most have been based on a proposed standard RFC 3195, which was designed specifically to improve the security of syslogs. So prior to RFC 3195, a lot of syslogging was just, like I said, happening in a broadcast fashion, not using TCP, but using UDP. And so implementations for reliable logging should use TCP, right? Transmission Control Protocol, where possible. TCP is a connection-oriented protocol that attempts to ensure the reliable delivery of information across networks. Using TCP helps to ensure that log entries reach their destination. Having this reliability requires the use of more network bandwidth, and also it typically takes more time for log entries to reach their destination than with UDP. But with acknowledgement of receipt of the packets, it's actually, it's usually more important to make sure you have all the packets than the speed with which they are transmitted. Of course, if you're operating an operation, an infrastructure like Twitter, for example, and you're having logging for millions of users or hundreds of millions of users potentially, I can see why there might be a combination, right? You may actually have certain types of logging events over TCP, and then other types of logging events which aren't terribly significant, and maybe they aren't transactional, like a password change or a posting of a message. Those could be done on a high road or fast or slow lane, I guess you could say it, where TCP is used for some and UDP is used for others. And then you can always try to reconcile the two. Sorry, keep yawning. I think I need an extra coffee today. Let's see. Another aspect of logging architecture was that I wanted to mention was transmission confidentiality. So you could recall I mentioned RFC 3195, that it recommends the use of transport layer security, TLS, as a protocol to protect the confidentiality of those transmitted logs. TLS can protect the messages during their entire transit between hosts. TLS can only protect the payloads of packets, not their IP headers, which means that an observer on the network can identify the source and destination of transmitted log messages, which could possibly reveal the IP addresses of the syslog servers, for example, and the log sources. Some syslog implementations use other means to encrypt network traffic, such as passing syslog messages through secure shell tunnels, which then would be shielded from having the IP headers inspected by a bad actor. SSH is the protocol for secure shell. So you can route your secure logs over SSH, for example. The third and final area that we're going to talk about for logging architecture is transmission integrity. So RFC 3195 also recommends that if integrity protection and authentication is desired, that a message digest algorithm be used. So let's say in the event of a system compromise by an attacker, the secure remote logging of the system security events is necessary so that the evidence of the breach and what commands and processes the bad actor have performed is available. If the local system is used, these logs can easily be deleted or otherwise manipulated to hide their presence on the system. Shown here is a photo of quantum entanglement from 2019 by researchers in Georgia, showing a situation where particles can remain connected such that the physical properties of one will affect the other, no matter the distance, even miles between them. The so-called action at a distance is not the first time that we've struggled to find the medium by which quantum entanglement can occur. Recall that gravity itself was first considered quite outrageous by the Royal Society, and early scientists actually came up with the concept of ether, A-E-T-H-E-R, as a space-filling substance that was thought to be necessary as a transmission medium for the propagation of electromagnetic or gravitational forces, such as between the Earth and the Moon. And so they didn't believe that there was, gravity could work action at a distance. Newton was actually quite the heretic at the time for inventing, or not inventing, but asserting that such a thing occurs. And of course, people needed to grapple with it, just like we're grappling now with quantum entanglement. We believe there can't be this link between things that are miles apart, and that if you affect one particle here, the other particle is somehow also affected. But certainly Eastern science has believed this, in Eastern medicine and Eastern philosophy has believed this sort of totality of existence and its connectedness, inherent connectedness, for many hundreds of years. And certainly there's some evidence now to be seen in subatomic physics and research that the Western view of science and these discrete laws, certainly at the non-subatomic level, is just an approximation, and it's not terribly accurate, and that it's much more like the constant creation and destruction, the dance of Shiva, for example, that is at the heart of matter and existence and what we call substance. All right, so observability. I also wanted to talk about tracing. So when we shift from using these monolithic apps to using microservices, it has basically driven the need to adopt what's called distributed tracing APIs and frameworks. So distributed tracing, or also called distributed request tracing, is a method used to profile and monitor applications, especially those built using microservices architecture. So distributed tracing helps pinpoint where failures occur and what causes poor performance. Open tracing is not a download or a program. In this case, open tracing, it requires that software developers add instrumentation to the code of an application or to the frameworks used in the application. In this case, tracing is data that shows which line of code is failing to gain better visibility at the individual user level for events that have occurred. So distributed and open tracing is used in a lot of mobile apps. Think of streaming apps like Disney Plus, or ESPN or Netflix. They're going to be using distributed tracing techniques to make sure that they know whether it was, the network, right? Oftentimes these things are being streamed over wireless networks. Whether it was a server problem, whether it was a database server problem that caused drop packets or buffering problems for users, because obviously they don't want the user experience to be broken by buffering of the image, right, of the stream. And so there's all sorts of techniques that are used to kind of instrument and imbue in these traffics and packets who is operating on it when, so that it can come back in your monitoring stack and you can actually have much better understanding. When you just had a client server and a monolith app running on the server, everything was happening on the server, right? But now you have APIs that are a part of multiple ways of streaming data and having metadata about what's going on about the stream, whether it's Zoom connections or other types of technology. All right, so let's see, what's the difference between tracing, and tracing? This was funny. I wanted to throw this in here because this was a good description that I found. I didn't put this particular diagram together, but tracing is how you monitor your system and get insights into its performance. Tracing is about recording transactions. Tracing is using the context that comes into a service with a request to propagate that context to other processes, and it attaches it to transaction data sent to a tracing backend. This context allows the transactions to be stitched together later. So think of a mobile application that's taking a long time and potentially failing or timing out. Tracing is instrumenting data in the mobile app request, which can allow you to find the request on the API being communicated with. And of course, it's passed to the business logic processes, and that winds up being processed on the backend database. It enables end-to-end transaction tracing so that all steps, down to the stanzas of code and specific application libraries and packages that are being used in processes, can be observed in your monitoring tool. Was this video stream of Tiger King stuttering and buffering, because of a load on the Netflix platform? Your local Wi-Fi signal having problems or interference? Or perhaps your signal being transferred to another cell tower as you speed along the LIRR heading home, right? The Long Island Railroad. Of course, this is back in the day when people used to go to work, but you get the idea using the example. And of course, Tiger King was quite the popular show, previously when I was putting together this slide. But you could obviously fill in, any other popular video stream that people are watching these days in this example. Application service maps. These are useful as far as audit and observability. Application service maps are visualizations of the application service and its components. Shown here is an example from a New Relic APM module. APM stands for Application Performance Monitoring. The cool part here is that if distributed tracing is built into the application, whether that's a mobile app or a web-based application, you can drill down and identify which components are causing the performance problem and to eyeball the data and see what the cause might be. So in this case, you can see that there's a load balancer and a dev instance. It's running a Ruby app, and there's a browser obviously hitting that. And there's a login service, and there's something going out to, looks like maybe US East in Amazon. And then there's 3 apps, grouped and talking to the database. And so all of this can be put together, and you can actually see what the requests, per minute are with this type of monitoring. And like I said, the app, the client browser, could well be a mobile phone, or a desktop browser. And of course, you look at it in different environments. But anyway, so this was one of the alerts that I think showed service maps in New Relic. Yeah. Other organizations have the same kind of thing, right? New Relic's not the only company doing distributed tracing and open tracing. There's plenty of companies participating in that standard and supporting it to allow interoperability, between different application components. All right, let's see. Next up, observability. I think we were going to talk, or I was going to talk a little bit about metrics. Metrics describe a particular process or activity that's measured over intervals of time. So generally, a group of metrics will typically be used to build a dashboard that is reviewed on a regular basis to understand performance, to understand alert frequencies, capacities, and trends in resource consumption. KPIs, key performance indicators, are selected from a variety of metrics that are available. Defining the log management approach for an organization depends upon the kinds of data that's being collected and how that data is used to inform the practice of information security and observability. How much raw data is generated and how much should be preserved on what we call hot storage, expensive disk, because it's accessible quickly, versus how much should be aggregated data should be preserved for a reasonable look-back windows for security log events. Do you need 6 months of raw data and 2 years of aggregated data? Perhaps. Maybe some people want to have 12 months of raw data and 3 years of aggregated data. How important is it to be able to compare Q4 website traffic and transactions for an e-commerce site across multiple years to know whether or not this is regular performance or expected normal performance or not? I think the graphic that I used here, that one probably is also a New Relic image that I found somewhere as well that someone had put together. Just an idea of what metrics might look like. Also in the theme and topic of metrics, we have sophisticated analytics that are available to reduce false positives with multivariate anomaly detection, event deduplication, advanced filtering, tagging, and sorting. All sorts of interesting information, of course, comes from the raw data, and we like to keep it around to preserve for analysis. But when you're building an analytics platform or configuring a third-party tool, we must choose a model for a metric's normal behavior, which includes any and all seasonal patterns in the metric and the specific algorithm used to find seasonal patterns. Like an e-commerce site that has lots of traffic around Christmas time, for example, or Thanksgiving, and then doesn't have a lot of traffic the other 10 months of the year. Does the volume of traffic increase on weekends or does it decrease on weekends? That depends on the business being analyzed and the nature of the exposed services. And of course, also the backend services that support internet-facing interfaces. So we work to tune the model to detect anomalies and to find actionable signal in the data. So here's a basic visualization of what deduplication looks like. Here's another example from a New Relic APM Insight dashboard that shows errors by application, top transaction errors, HTTPD response codes, and CPU load. So InfoSec is more concerned with the server 403 response codes, for example, which is permission denied, for example, and defining a threshold above which an alert should be generated. An example of this might be when someone is throwing a breach data set, right, from the dark web at your login API, and you see an influx of permission denied errors. So the site is still performing and it's responsive, but as the attacker ramps up their requests per minute, you might need to employ some rate limiting controls to help keep the service from being overwhelmed and potentially crashed. And so this was, again, an example I found from the internet. Tower Washington, Tower Dallas, Tower Phoenix. I wonder what type of transaction these were. But anyway, it's a simple example of what some of the visualizations of these audit and observability metrics might be. Here's a better example. In this example, the web transaction time clearly shows that some kind of event at around 10:10 a.m. Was there a release that was deployed that contained a memory leak, causing the PHP response times to leap from around 100 milliseconds to 1,000 milliseconds? Why did the MySQL response time expand as well? Looking at the throughput graph, the time period does not show an increase in the number of requests per minute. It averages around 83.1 RPM, or requests per minute. So in my estimation, it's something in the code itself, right, that has gone wrong, that caused this particular violation of the transaction and responsiveness. And so you can tell, through good instrumentation and monitoring, that the throughput was held pretty constant. The AppDex, score went down, of course, as soon as the millisecond response times, for the PHP part, leaped from below 250 to around 1,000, and the total response time spiked to almost 1.7 seconds, 1,700 milliseconds. And of course, you can track that specific handlers and app server times went up for various traces, and then you can drill down on them and look at the details and figure out what's going on, hopefully. All right, so one more thing on metrics. Time series data lends itself to metrics and KPIs, which are inherently time-oriented and repeatedly sampled. There's one important thing to keep in mind. The time series data itself is a record, not a projection. That record, however, contains information which can allow us to make educated guesses about what we can reasonably expect in the future. And so time series data, oftentimes these metrics are used to calculate what they think the error rate will be for the next hour. And then, of course, if the error rate deviates from the calculated or projected error rate, you can actually have dynamic capacity planning and monitoring that changes based on baseline loads changing. So you have much more sophisticated monitoring capabilities than just setting an absolute number and saying whenever it goes over above or below a particular threshold, an alert is fired. So you can have what are called dynamic or vector-based baselines. What else? Mobile KPIs, mobile app KPIs. These are some things that many people would want to track. For example, if you have a business and it has a mobile app, you want to look at your daily active users or potentially monthly active users if they don't log in every day. You want to track the number of application installs, the number of in-app purchases, and of course, the number of sales of the application or purchases of the application by geographic location. And so here, what you're seeing is just some data that I think I pulled down from worldwide downloads from, I'm guessing, it was Sensor Tower. It's looking at App Store versus Google Play across a set of apps. And this was, I think, Q4 2019 or something data. But you can get these reports from Sensor Tower and get fresh ones. I pulled down a couple of fresh ones just for today's class. But this one I wanted to show. Let's see, I think this one's fresh, yeah. So this one is App Store top 10 US games. And you can obviously see, or maybe not, no, this is probably all categories, yeah, not games. TikTok obviously is way up there. Of course, Minecraft, YouTube, Instagram, Snapchat, all the usual suspects that you might expect. Next up is, let's see. Yeah, this is the games graph. So anyway, Sensor Tower, you can get a free account there and you can get some interesting data and understand what's happening on the mobile area. I didn't realize Hair Challenge is doing so well. And this is just for May 1st. But some of the other games, of course, Roblox, which is more of a gaming platform on which you make micro games. But you can see, of course, Call of Duty is in here, Magic Tiles, Project Makeover, Heads Up. Oh, that's, I think, one of those fun trivia games, right, where you hold up information and you have to guess what's written on it. What else? Roblox is listed on here under top grossing. Oh, yeah. So the first column is free games. The second column is paid. And the third one is top grossing so far. And let's see. Yeah, I had Marvel Future Fight reviews, downloads, and revenue per March 2020. So the first app that you track when you sign up for a Sensor Tower login is free. And so this one happened to be in my account from a few years ago. This information is publicly available for your info at sensortower.com. But basically it showed, March, there were 100,000 downloads, not a lot of reviews happening per day, but you can see some negative reviews there as well. And this is using sentiment analysis to figure out whether someone's unhappy with the game purchase or not. And of course, that's not bad to have $1 million in revenue worldwide for the month of March for this Future Fight game. from, I believe, Netmarble is the producer. I did pull down a more recent one because I don't know if Among Us existed when I first created this course. So I pulled down the stats for Among Us. And of course, this shows a lot more reviews going. And interestingly enough, I think these are probably when different releases are coming out, March and April. And you see these spike, in positive and negative reviews. And 4 million downloads in the month of March, and 800,000 in revenue worldwide. So that's quite significant. And Among Us, of course, is a great fun game that teaches actually game theory to children who play it, in terms of the imposter and the crew, and killing one of the crewmates and pretending to act like you're a crewmate even when you're the imposter. You actually have what is known as imperfect knowledge when you're a crewmate, but when you're an imposter, you have what's called perfect knowledge of the system, because you know who the imposters are, or at least who you are, that you're one of the imposters. Anyway, lots of fun aspects to mapping game theory into InfoSec. I teach a course on that periodically for Hacker University, which is quite fun, 3-hour class on talking about game theory as it's related to cybersecurity and different types of threat actors. And what was the main principle that we talk about? It was the subject of the movie A Beautiful Mind that was played by Russell Crowe. John Nash, right? And so the Nash equilibrium is often a topic of discussion when we talk about InfoSec deterrence, for various bad actors, and their ability to work together or not in the prisoner's dilemma and things like that. Anyway, so that's for another time, but this one is March 2021. In the world of metrics and observability, of course, e-commerce KPIs are often quite important for us to track. Net revenue, shopping cart abandonment, average order value, conversion rate, churn rate, of course, because it's more expensive to get and acquire a new customer than it is to retain them. And so churn rates are much more important sometimes than customer acquisition costs, because you want to keep the customers you have and not have to get new ones all the time. So here I think I have some data from Statista from 2020 on the annual net revenue of Amazon from 2004 until 2019 in billions of dollars. And so this is amazingly significantly growing. Obviously, I'm not sure what the 2020 revenue for Amazon is. I'd have to look it up for their e-commerce, but I'm guessing, looking at this curve or this graph, that it's probably well above 300 billion, and probably because of the pandemic could easily be 400, 500 billion, given all the online shopping that's going on instead of in person in brick and mortars locations. Another aspect of metrics for observability is the conversion rate in the US for holiday season in 2019 by device. So we're looking at desktop versus mobile. Again, a lot of really great stats on statista.com that shows the source, and Thanksgiving, and Cyber Monday versus the regular holiday season, and desktop versus smartphone breakdowns of that information. Let's see, what else? Let's see, I think this one came from Akamai. Yeah, this particular graph. So think about daily malicious login attempts across 2019, according to Akamai's SOTI. This is an abbreviation for their State of the Internet report. And I think I added it to the GitHub repo for your optional reading, but you can always download the latest one, 2020, 2021, SOTI from Akamai. So they have some stuff in here on InfoSec that's useful. An analysis of Akamai's ESSL network revealed an 83% to 17% split between API and HTML traffic on their secure content delivery network, their CDN. That means 83% of all the traffic that Akamai is caching out there is not actually meant for humans, right? HTML is meant for humans. API is meant for apps and for machine-to-machine communication. And this is a significant increase since the same survey was performed back in 2014. So this means a significant majority of fraud is also happening over APIs, and strong analytics are needed there to observe and mitigate attacks and credential stuffing vulnerabilities and all sorts of crazy uses of and abuses of infosec oversight. Maybe we don't always get a chance to review the application security or the user behaviors. One other fun thing that I thought I would throw out here, when discussing credential stuffing attempts, one of the key themes is the use of easily guessed or weak passwords. So in addition, far too many users recycle their passwords across multiple networks and services. For example, early in March 2019, I think, stories from Comcast's Xfinity mobile phone service having a default PIN of 0000 on customer accounts came to light. This story circulated shortly after rapper and business mogul Kanye West was shown to have set the password on his iPhone X to 000000, right? You just saw him push it like 6 times on this video clip of him speaking with then President Donald Trump. And anyway, these kinds of bad user behaviors are things that we have to deal with. Let's see. Akamai's State of the Internet 2019 report also talks about SQL injection being the top threat when it comes to web application risks, SQLi. And it accounts for nearly 2/3 of all attacks. Overall, the US is still the top source for credential stuffing, followed by Russia. But when looking at gaming data alone, then Russia is the #1 source. Next, customer churn rate in the US in 2018 by industry, another Statista report. And it looks like different industries have different churn rates. And of course, if your churn rate is better than others, then you're doing well. And you need to understand why, though, right? You can't just be lucky. You have to have a theory, and you have to test that theory and understand churn and make it a part of your business. Analytics and the business and InfoSec go hand in hand in that regard. All right, so let me jump and change gears for a second. All right, so change control and SDLC. So change control is a systematic approach to managing all changes made to a product or system. The purpose is to ensure that no unnecessary changes are made, that all changes are documented, and that services that are not necessarily, make sure that services are not unnecessarily interrupted or disrupted, and that resources are used efficiently. In systems engineering, information systems and software engineering, the systems development lifecycle, also referred to as the application development lifecycle, is a process for planning, creating, testing, and deploying an information system. The systems development lifecycle concept applies to a range of hardware and software configurations, as a system can be composed of hardware only, software only, or a combination of both. There are usually 6 stages in this cycle: requirements analysis, design, development and testing as one, implementation, documentation, and then evaluation. There are also, I should mention, 5-stage and 7-stage SDLC models, but let's take a look at the 6-stage model. Change control. So CAB, right? Change Advisory Board. That's what CAB stands for. In many organizations, especially ones that are doing continuous development and implementation, they're going to have less topics coming forward to a CAB, right, where people meet maybe once a week. And so that's usually why this is for larger scale projects, right, that impact multiple teams, for example. So the CAB members should be selectively chosen to ensure that the requested changes are thoroughly checked and assessed from both a technical and a business perspective. The considered change will dictate actually the required personnel to convene in a CAB meeting. Some companies have a standing CAB meeting for large changes, and of course delegate change control approvals to an LCAB, which would be a local change advisory board. With the advent, like I said, of CI/CD, the role of the CAB sits more with strategic rollouts of new platforms and integrations or features that require a much broader cross-functional perspective to discuss the risks and the rollback plans for these changes and major maintenance activities. The CAB is responsible for oversight of all changes in the production environment and should have representation from architecture, engineering, security, QA, and of course the business itself. So here is an example of a 5-stage SDLC. Requirements and analysis are rolled together. Then of course design, implementation, testing phase, and then evolution, which feeds back of course into the next development cycle or requirements analysis. Here's a 7-phase SDLC with mapping the SDLC phases to management control domains. I'm trying to remember if I know where I got this graph from. No, I don't have a note on that. But anyways, this is a 7 phase. And in the 7 phase, let's actually take a look at each phase for a minute, because the 7 phase one is going to have more granular breakdown on some of the tasks for each of the phases. So we have planning separate from analysis, then we have design, then comes development. After development comes testing, then implementation, then maintenance, and then sending it back around again. So let's take a look at each phase and note the relevant tasks and activities. So SDLC planning phase. This is where resource allocation, both human and materials, are discussed. Capacity planning is introduced, project scheduling, cost estimation, and of course, provisioning discussions. The outputs of the planning phase include having a project plan. You will also come out of the planning phase with a schedule. You'll come out with some basic cost estimations. They can be wrong, of course, but these would be what was estimated to begin with. And procurement requirements for procuring the people and resources needed to deliver the project or the feature or software. Ideally, project managers and development staff collaborate with operations and security teams to ensure all perspectives are represented. Certainly when we're talking about requirements, we want the non-functional requirements for high availability, disaster recovery, BCP planning, authorization and authentication. All of these should be included as functional and non-functional aspects. Next, the analysis phase. Analysis of the requirements to communicate with IT teams and others to convey details for a new development or an enhancement. One of the things that's an output of this phase in a waterfall project is usually a document that lists these requirements. Agile methods, by contrast, may produce a backlog of tasks that need to be performed and that will be picked up at some point in time. Let's see, next up, the design phase, processes that use established patterns for application architecture and software development. So in many cases, you want to go with a tried and true design and find one that's applicable or suitable to your project. Developers use proven design patterns to solve algorithmic problems in a consistent way. How to perform search functions on the data if you're introducing search features or filtering features, for example. This phase may also include some rapid prototyping, also known as a spike, to compare solutions to find the best fit. The output of this particular phase includes design documents and diagrams that list the patterns and components selected for the project and code produced by those spike activities. And of course, it's used as a starting point now for development. The development phase, it produces working software as quickly as possible, whether in an agile or in a waterfall approach. Business stakeholders should be engaged regularly to ensure that their expectations are being met. The output of this phase is testable functional software. And of course, there's lots of great expectations that need to be managed. And that's one of the reasons why I threw in the Charles Dickens book here. Of course, in the testing phase, we're talking about code quality, unit testing, and functional tests, integration testing, performance testing, and last but not least, security testing. The best way to ensure that tests are run regularly and never skipped for expediency is to automate them. The output of the testing phase is functional software ready for deployment to a production environment. Finally, we reach implementation phase. The deployment phase is the implementation phase of software and ideally a highly automated phase. The output of this phase is the release to production of working software. And of course, finally, the maintenance phase, software must be monitored constantly to ensure proper operation, which feeds back into the SDLC. The operations and maintenance phase is the end of the beginning, so to speak. The software development lifecycle doesn't end here, though. Software must be monitored constantly to ensure proper operation. Bugs and defects discovered in production must be reported and responded to, which often feeds work back into the process. And of course, there's a retirement phase that comes when you turn things down, like deprecating the use of Adobe Flash, for example. We finally reached the final phase of Flash. I think it's dying finally. Let's see what else. Change control, SDLC security touchpoints. Yeah. So moving automated security testing tools into each phase of the SDLC is really a great return on investment and improvement for security. Security issues are fixed with less effort and cost less when they're identified and remediated in lower environments, non-production environments. Security should not be thought of as a single hurdle to be addressed just prior to going live. And so in this case, I'm talking about, threat modeling can be happening in the design phase. Of course, we can have all sorts of security and privacy requirements in the requirements phase. Of course, in development, we can have static analysis of the software and the packages that are used, scanning for, vulnerable packages of Nginx or Tomcat or Apache or other types of libraries that are used in the software development, and then peer review and scanning can help with that. In the testing phase, you should definitely have tests, cases that are used to make sure that OWASP top 10 have been addressed, for example, or the CIS 20, top 20 have been implemented, and you can detect that using dynamic analysis, as well as an additional round of static analysis tools. And then, of course, in deployment, you have your final security review, and you have application monitoring and making sure all the logs are there and that you have bad people try to break the software, not just QA it that it works as function, but people that intentionally do what might be called evil QA in order to find out whether there's logic flaws in the code or bugs that can be exploited or really horrible assumptions. Oh, and my favorite example of a really horrible assumption is that on Monday, Apple came out with Mac OS 11.3, and they said there's a bunch of zero-day vulnerabilities. Everyone should apply it and fix it. And they came out with an update for iOS as well, I think, which is 14.5 or something. And what's amazing that I found out recently was that one of the 0 days is this horrible assumption that was made by Apple in their Gatekeeper program. So if you're familiar with how Apple software development works, only authorized App Store apps get moved into apps and installed on a Mac, unless you're bypassing the Gatekeeper and saying, I trust the source of this software and this program that I'm going to run. But what somebody found out was that the entire Gatekeeper function of checking to see whether the program has been submitted to Apple and notarized and signed and considered to be trusted, software that was reviewed by people that are paid to do this. It was actually searching for the existence of an info.p list, which is kind of like a manifest or a packing list for your software application. And the silly thing is, and the researcher found this by dumb luck, I think he admitted, but that he was baffled, that it actually worked. All he had to do was delete the info.p list. And instead of Gatekeeper rejecting the app, saying, hey, I don't even have your packing list, I'm not going to let you install and have system privileges and things like that, it actually thought, well, you're not an app, you're good, you're free to go. And so this was actually a huge vulnerability that was being exploited in the wild by adware, that someone had found out about this and tinkering, and I'm sure some malware was aware of it as well. And so you'd think that Apple has been doing this really, really well for many, many years. I know I'm in the school of thought that, such a gross assumption, about the nature of applications that are being run and installed on computers could have been subject to such a very gross mistake in logic. I mean, this is amazing that that's what that 0 day was about. So anyway, if you haven't updated to 11.3 or 14.5 on your Mac and iOS devices, I highly suggest that you do it as soon as possible, because this was a huge fundamental, oversight in testing and in security for Apple's Gatekeeper product and keeping all of our computers safe. All right, so looks like we're about an hour in, and I'm halfway through the slides, so that's good. Moving along at a good clip. We can definitely reach the 2.5 hour point and have a little bit of time, hopefully, for InfoSec in the news this week. But anyway, I just mentioned one news story just now. All right, so remember I talked about this concept of who's watching the watchers, right? Let's see. My Latin isn't very good, but I think it's something like quis custodiet ipsos custodes. And this translates to who will guard the guards themselves. So the original context for this deals with the problem of ensuring marital fidelity, though the phrase is now commonly used much more generally to refer to the problem of controlling the actions of persons in positions of power, an issue that was discussed by Plato in the Republic, actually. For InfoSec, the admin or the super admin role is the watcher. So who has the oversight and audit role to understand the activity and monitor the potential for abuse of that power and system access? After all, the super admins and DBAs, they can read all my email. They can query all of the databases, and they can access pretty much any information that might exist on a platform. So how do we address this? Well, periodic audit, dual controls, and of course, non-persistent privileged access. So these are some techniques that can be employed. Periodic audit, this phrase is used, like I said, generally to consider the embodiment of the philosophical question as to how power can be held to account. There are at least 3 areas of security design that can address this problem. Periodic audit can help ensure that those with privileged access do not feel able to abuse it. Dual controls can also be implemented on systems to ensure that both legal and HR are engaged in order to authorize access to privileged roles on platforms that have access to sensitive information and data. And lastly, setting up non-persistent access for privileged roles helps limit the potential for abuse. So only allow what are called break glass credentials and access rights to look into personal folders on file shares, for example, when there is a documented and improved reason to do so. And so having non-persistent privileged access also stops and limits the blast radius of anything that might happen for a user browsing the internet and reading their email, clicking on an attachment in that email when they are a super user. And so this is also a good concept to apply and then of course the periodic audit is to have someone maybe from the legal team, sort of shoulder surf a super admin or an InfoSec privileged user periodically and just say, okay, I want you to go and log into the HR system and take a look and make sure that there's no accounts that have been created by the HR team, for example, that there may be stealing money or having paychecks sent to a non-existent employee, which they're taking the money from. And so shoulder surfing on the admins for HR or for the InfoSec team, you'll be able to actually see whether they use two-factor auth to get into that position of reading the information in that system, or just doing a check and saying, what were the last 100 transactions, from the accounts payable or payroll system. And so that periodic audit is the specter of being seen doing it, or if they do it and they don't actually use multi-factor auth and they just log in immediately, that would be a flag that should go off for the person who's auditing and watching the watcher and saying, wait a minute, you should definitely have to pull a credential out of a password vault or something before you can access the system. You shouldn't just be able to log into it at any old time whenever you want. Well, so anyway, that's a little bit about non-persistent privileged access and dual controls and periodic audit. Let's see, what else? The execution of a periodic audit or access is one way to mitigate the problem of watching the watchers. These systems must have clearly stated and widely understood procedure for allowing access via alternate and or manual methods. Also the break glass situation where your super admin is sick or unavailable, maybe they're on holiday. How can they get that credential and access the password vault, for example? And that's one of the examples I want to mention. administrative user for a password vault. So the periodic audit of privileged access needs to not, be more than, doesn't have to be more than much, like I said, the shoulder surfing session with someone who has the super user credential available to them. So an executive or two can sit with the technical administrator of the password vault and observe them, performing the break glass and leveling up procedure to become, God mode on the password vault to see what someone's password is, for example, in one of their private accounts. Because they should all be business related, of course. Demonstrating that the process is documented and, of course, seeing it followed in person. This periodic audit helps make sure that the access of the watchers is made into an observable event. Shown here is a depiction of a scene from Guardians of the Galaxy 2, where Stan Lee has a cameo talking with the characters known as the Watchers. So obviously I pulled that in because of the Marvel reference, and also it's just a nice fun drawing of Stan Lee. I don't know if anyone saw that movie, but it was a fun, quick little cameo flyby scene when they were flipping through galaxies, if I remember correctly. All right, so what is dual controls? Two people are required to perform a task of one person. Shown here, two missile commanders simulate key turns of the Minuteman III nuclear weapon. For information security, some processes such as starting up an insider threat investigation are best linked to a dual control setup, where both HR and legal, for example, should approve the installation of surveillance software on a user's workstation or account, key loggers, things that pull down their browsing history, things that take pictures, screenshots, screen recording. Having the dual controls in place helps ensure that capricious use of user monitoring and surveillance tools is unlikely. Non-persistent privileged access, right? Using a separate admin account from their normal account. This deters abuse and limits the impact from threats and attacks. You may have heard of the interns or 20-year-olds working at Fricata, the internet camera company, who had access to hundreds of thousands of cameras across the fleet. That is not non-persistent privileged access. That's widespread violation of least privilege and this non-persistent rule that I'm talking about. It's not the fact that a domain administrator has access to privileged information and data. It's the fact that they might have unrestricted access to that leveled up user access 24/7. It's the persistence of that access to that privileged role that is the issue that needs to be addressed. Using a password vault and having separate admin credentials, that's an effective way to mitigate the risk of abuse and also the impact of threats and attacks. Over 80% of Microsoft vulnerabilities can be eliminated by simply removing local admin rights. Sudo permissions in Unix and Linux systems are one way to provide very targeted permissions for users on specific systems for specifically designated commands, rather than just giving them full root user access, right, to a root shell that can do anything. And so if you can carve out 10 or 15 commands and put it in a sudoers file on Unix and Linux systems, that's a much more controlled way. And they don't even need to know the root password at that point because they're just typing their own password when they run sudo. If you're not familiar with sudo, it's spelled sudo, and it's a particular technique that's used, like I said, on Unix and Linux to allow privileged roles and access without actually having to know the password. So you type your own password, and then there's an audit trail and log file that gets created saying that you used an elevated privilege and command. Let's see, non-persistent privileged access. Oh yeah, let me explain. Sudo is a method for delegating root level permissions to a user or a set of users without giving them full root or admin access. Sudo is a program for computer, Unix-like, that allows users to run programs, like I said. It originally stood for super user do, as the older versions of sudo were designed to run commands only as the super user. And of course, this is what an XKCD comment. Rob M at Homebox, he ran sudo su, which is essentially to become the super user, right? Su is switch user, and if you don't type in a name, you're basically becoming the super user. So you don't have the password, and it says, oh, Rob M is not in the sudoers file. This incident will be reported. And of course, hey, who does it actually get reported to? And the person he's asking says, I've never checked. And of course, here's the joke, that it's Santa Claus. And he's putting you on the naughty list because you tried to become super user on a system with that sudo su command. Here's an example of a sudoers file that I used many years ago in building the PlayStation.com infrastructure for Sony, Computer Entertainment America. So there's a host entry, a host alias, right? A user alias, a command alias, and then you put them all together, right? So in this case, Sony DB is the alias that has two entries. Sony-Sun-DB-P-1. So in this case, it was a Sun Solaris machine. It was a production database. So the DB is database and the P is production. And then, of course, there's two of them, right? Because you can never have one database. You always want to have at least two of something. And then, of course, Sony DBAs, T Horsma, C Pesco, and Jim N. Those are their usernames. Those are the DBAs that can run the command. And then, of course, the command alias says they're allowed to become the Oracle user, which is running su-oracle. And so they would say sudo space /bin /su-oracle. Or they could just run sudo space /bin /su space oracle. And the difference is you're picking up Oracle's environment variable if you do su-oracle. And if you just do su oracle, you're becoming the Oracle user, but you're keeping all of your own environment variables. So let's say you have certain path to Java or Oracle Home or things like that. Anyway, so you need often to have multiple commands in a command alias. These are just two. And you put it all together. So the last line says Sony DBAs are allowed to become Oracle on Sony production databases. And that's often used for troubleshooting. You might actually lock out their users, outside of a maintenance window so that they can't even log in. But once they can, then they can do their work and become the Oracle user and look at logs and bounce processes and potentially fix things, right? Or it could be that you have SREs, right? Site reliability engineers that are in your user alias. So anyway, I highly recommend using sudoers files wherever you can, wherever appropriate. Break glass. I've often talked about this, and maybe it's good to spend a minute describing what we mean by this. Break glass refers to a quick means for a person who does not have privileged access to gain the information and that access when necessary. So systems containing confidential restricted data such as super user or super admin credentials, they must develop, document, and implement and test break glass procedures to be used in the event of an emergency where you require someone that normally doesn't have that access to gain it. And shown here, of course, is a fire alarm, with the whole break glass metaphor there as well. All right, so now begins a whole section on threat intelligence. In military terms, cyber warfare is an asymmetric war. And the best result that attack targets can achieve is essentially a draw. It's now a question of becoming more proactive by moving beyond the technical details of the attack, the what, the when, and the where, towards a better understanding and attribution of the tactics, techniques, and procedures, TTPs, behind the attack, the modus operandi, or the how, and critically, the attackers themselves, right, the who and the why. But before we get into cyber threats and threat intelligence, let's examine the traditional threat landscape. The traditional threat landscape was land, sea, air, and space. From a traditional military perspective, there were only 4 operational domains, right? Land, sea, air, and space. You met the enemy in a physical location at a specific moment in time. Cyberspace, however, is entirely man-made. Traditional threats were bound by these constraints with regard to geography and moving one's troops and weapons and resources to the theater of operations. But for cyberspace, the theater of operations has to be created. It's only through continued attention and maintenance that the theater of operations actually persists. Networks, computers, routers, switches, accounts, websites, right? This is the theater in which cyber warfare is taking place. So here I have a typical drawing of a battle, right, of what it was like in the olden days. But we don't have those benefits anymore. Cyberspace as a concept describing essentially a widespread interconnected digital technology. The term cyberspace first appeared in fiction in the 1980s in the work of cyberpunk science fiction author William Gibson, first in his 1982 short story Burning Chrome, and then later in his 1984 novel Neuromancer. In the next few years, the word became prominently identified with online computer networks. Gibson actually commented on the origin of the term in the 2000 documentary, No Maps for These Territories. And I quote, "All I knew about the word cyberspace when I coined it was that it seemed like an effective buzzword. It seemed evocative and essentially meaningless. It was suggestive of something, but had no real semantic meaning, even for me, as I saw it emerge on the page." And if you don't follow William Gibson on Twitter, I suggest you do. His account is at Great Dismal. And actually, a lot of his best insights come from his wife, which is Mrs. Dismal. And when they're browsing the internet, finding oddities and strange things, I always like to find them and follow them. So William Gibson is certainly someone that I follow on Twitter. Cyberspace dimensions, right? It has 3 dimensions: physical, informational, and cognitive. An interesting way of describing cyberspace is to ask the question, where are you when you're on the phone? Now, obviously, you know where you are physically when you're on the phone, but I think you get what I mean here. Shown here is a frame showing hyperbolic space tiled with dodecahedra from a 1990 film entitled Not Not, which is spelled Notknot. And what's interesting, of course, is this was produced by the University of Minnesota supercomputer project. And it shows that you can actually tile hyperbolic space perfectly with these regular rhombic dodecahedra. And it's called Lobachevskian or hyperbolic space. And what they do is in this video, they actually fly around in it. And it's very disorienting. It's kind of like being in a non-sober state. And anyway, I found it fascinating, this film, because math and knot theory and complements of knots are really quite powerful in explaining, some of the higher order n-dimensional math problems that we run into. And so just a fun reference there to a 21-year-old film now, I guess, at this point. So the graphics won't be too impressive based on modern, techniques and graphics processors. But back then, you needed a supercomputer at the University of Minnesota to make a video like this. And they eventually reduce, all of these vertices, the red, green, and blue vertices for what would normally be like a 3-dimensional cube into a hyperdimensional cube. They keep reducing them to infinity, and they find that these interesting patterns emerge essentially as they fly around. All right, next up, the physical dimension. Essentially, this is the core technical infrastructure of networked hardware and software. And I don't have a problem, but some people do, of collapsing hardware and software into just one dimension, right? Because software doesn't run without hardware. And hardware is kind of boring and useless without software on it, right? So this comprises essentially the core physical infrastructure, right? Networked hardware and software across land, sea, air, and space. That exploits, the essential EMS, right, the electromagnetic spectrum, to enable the flow of information between producers, consumers, audiences, and systems. And of course, in addition to the physical, we have the informational, content or data at rest or in transit. So this is the content generally referred to as information, but it can also include data and knowledge. Remember that whole DKIY pyramid. That is at rest or in transit in cyberspace. It includes machine-readable content, numbers, text, audio, pictures, and video. It's also where cyber persona reside, right? Digital representations of individuals and other entities that use cyberspace and that have one or more identities that can be identified, attributed, and acted upon. As far as the third dimension of cyberspace, the cognitive, this is the knowledge, the values, the beliefs, the concepts, intentions, and perceptions of individuals and groups. These actors are the creators and users of the content, right, that moves through the physical layer. This dimension, it provides the basic societal, cultural, religious, and historical context that influence the perceptions of those producing the content and those consuming it. So in this case, governments, criminals, activists, and hackers, we all think, perceive, visualize, understand, and make decisions within this dimension. And so I much rather prefer this 3-dimensional definition of physical, informational, and cognitive than to the traditional sort of physical and digital, right? Or physical and virtual split, because I don't think that really covers this last aspect at all, to talk about the cognitive risk, because there are cognitive risks in cyberspace. People assume that certain companies are too big to fail, right? Like AWS, but they've shown that they actually can fail. They can mess up their entire S3 in the U.S. Eastern region a couple of years ago, and the whole thing went down, and everyone had an internet snow day, essentially, right? Because no one, servers and services were built fault tolerant enough to be able to survive, the loss of the S3 services for several hours back in, I think it was like a June or July. But anyway, so this is, for me, one of the most important aspects to spend time and attention on in the InfoSec program is thinking about systemic risk and cognitive risk, and how our beliefs about, how things work and failure, and, that humans are always clicking on things, and so humans are the weakest link. We really need to embrace failure in order to build resilient, fault-tolerant systems rather than fear it. And so, anyway, it's an area of work that I plan to do some writing on and try to express, the importance of paying attention to identifying cognitive risk. Let's see. In terms of cyber threats, with cyber warfare, you can really only deprive an enemy of two things: time and treasure. And I learned this from the deputy commander for the U.S. Cyber Command when he was speaking at a Bank of New York Mellon event a couple of years ago. And I kept it, and I wanted to bring it into this class, into this lecture, to make sure that you understood that at a more abstract level, cyberspace is an environment that's created and maintained for the purpose of facilitating information exploitation, and for the purpose of facilitating human interaction, and of course, transpiring and transacting general communications. It can be better understood, especially from an intelligence perspective, if it's viewed as being comprised of those three dimensions that I mentioned: physical, informational, and cognitive. All right, so let's talk a little bit more about threat intelligence. There is a threat intelligence lifecycle. It's the direction, collection, analysis, dissemination, and review. So the lifecycle model, as described here, has been kept simple for the purposes of clarity, and therefore, I think two caveats should be noted. First, such models can give an over-idealized impression of a very neat linear progression of activity between setting direction for cyber intelligence and threat intelligence, then performing the collection function, the analysis function, but it's not really that neat. But for the purposes of explanation, let's just pretend it is linear and clean. The second caveat is that the life cycle models can be misread as plans, giving the impression that all activities are of equal complexity and duration, which is not necessarily the case either. At the highest level, the threat intelligence lifecycle follows the classic computing process model of input, process, and output. And I took this from the Bank of England's description on the financial sector and understanding cyber threat intelligence and cyber threat operations. There's a link in the slide notes that you can see later that takes you directly to that PDF that I took this from. Threat intelligence lifecycle. So let's talk about the first phase, direction. The intelligence cycle begins with direction from the customer that consumes the intelligence product. The intelligence manager evaluates the customer's requirements to ensure that they are within the remit and capability of the intelligence team. They are then translated into specific intelligence collection, analysis, and dissemination tasks. In addition to the content of the intelligence product, how it should be presented and disseminated are also covered because there's different audiences, obviously, for threat intelligence. In the requirements phase, there's really three aspects that we want to pay attention to here. Short term, which is measured in days, and so it's extremely tactical in scope. And then, of course, there's medium term requirements, which are measured in weeks, and they're often about a very specific topic. And then, of course, there's long-term requirements, which can be outlined maybe in a 1 or 2 year timeline, and they're much broader in scope and are much more strategic than they are tactical in nature. Because threat intelligence is a cyclic evolutionary process, the direction phase will also, where appropriate, take into consideration the results, right, the successes and the failures of a previous loop around of the cycle when planning the next round of intelligence tasks. Next comes collection, right? Sources, strategy, and processing. So the collection usually consumes the greatest amount of budget because of the time, effort, and cost involved in collecting data from diverse sources. Constant monitoring of every possible piece of required data to a high degree of detail is not technically tractable, right? In addition, too high a volume of data risks overloading downstream analysis. An intelligence function will therefore need to shape its collection strategy. Here is, I believe, what seen from Minority Report with Tom Cruise using an advanced human-computer interface, gesture-based, with his fingers being tracked, for virtual controls. We have this now, I believe, in some Oculus-type gears and things like that. But anyway, so yeah, part of the collection of threat intelligence. Collection sources. So let's go into each of those three. These are overt human, covert human, open source signals. Overt human intelligence is derived based on human sources with relationships to the agent or the collector of the intelligence. Covert human intelligence is obtained by a person who establishes a relationship with another person for the covert purpose of using it to obtain or provide access to information. Open source, aka OSINT, is collected overtly from publicly available sources. A lot of the data for Security Scorecard, for example, falls under the category of OSINT. Looking at headers on web pages, looking at DNS records, looking at the contents of HTML that disclose information about how it was created, what type of service or application is behind it, and whether it's vulnerable. Signals intelligence, SIGINT, is derived overtly or covertly from the interception of signals, whether communications between people or communications between machines or electronics. Here I wanted to mention a SIGINT vehicle like this drone, the Northrop Grumman Global Hawk. The Northrop Grumman RQ-4 Global Hawk is a high-altitude, remotely piloted surveillance aircraft. It was initially designed by Ryan Aeronautical, which is now a part of Northrop Grumman, and known as a Tier 2 Plus during development. The Global Hawk performs duties similar to that of the Lockheed U-2. The RQ-4 provides a broad overview and systematic surveillance using high-resolution synthetic aperture radar, SAR, and long-range electro-optical infrared, EO/IR, with various sensors with long loiter times over target areas. It can survey as much as 40,000 square miles, which is about 100,000 square kilometers of terrain a day, basically an area the size of South Korea or Iceland. Certainly fun and interesting techniques and information in that schematic there. Anyway, next up, collection strategy. You have periodic, ad hoc, and event-driven collection strategies. So the periodic is, of course, monitoring the environment at a regular frequency or pulse rate, which may range from minutes to months or more. Ad hoc is monitoring the environment in, of course, an ad hoc manner that was driven by the current state of the analysis. Example, the current hypothesis under consideration in the threat intelligence mission. And then, of course, event-driven. This is monitoring the environment in an ad hoc manner that is driven by specific events occurring or anticipated to occur within the threat landscape, i.e. data-driven, essentially. These three are what we might call pull-based collections, but there are also push-based collection strategies and techniques as well. Threat intelligence collection strategy, I wanted to mention Echelon. Echelon, originally a secret government SIGINT program from the 1960s to monitor military and diplomatic Cold War communications. By the end of the 20th century, the system referred to as Echelon had evolved beyond its military and diplomatic origins into a global system for the interception of private and commercial communications, essentially mass surveillance and industrial espionage. So Jam Echelon Day was an inspired idea to overload echelon collection by inserting keywords into as many communication channels as possible on October 21st, 1999. A list of 1,700 suspicious words were listed on the CipherWar website to be included in email, telephone, and fax communications on JM Echelon Day. And of course, the trigger words included hackers, encryption, espionage, Secret Service, Bletchley Park. It's unlikely, of course, that this had any effect on Echelon. But awareness was raised by the event and awareness of global surveillance programs. So anyway, a fun reference for those of you that lived through it. There was also, I think, several years followed on as well, 2000 and 2001 JAM Echelon Day. But the very first one was in 1999. In terms of collection processing, yeah, you actually have to perform the collection, then you have to process the collections, right? So the information and data that's collected is processed to render it amenable for further analysis, right? Downstream analysis. Threat intelligence collection processing will involve the use of automated tools that can perform useful data processing functions, such as parsing the data, right? Making sense of it, normalizing it, correlating the data, filtering the data, deduplicating, and of course, aggregating. So this is a critical and often overlooked step in the threat intelligence cycle. Although it's generally described as being part of the collection phase, it could just as easily be said to form a bridge between collection and analysis. So if you're standing up a Splunk server, for example, a lot of this is going to be happening on the Splunk instance, right? Where you're parsing and correlating the data and being able to filter it and query it and deduplicate it, and of course aggregate it and figure out how often is something being attacked, right? Or how often does something, defend successfully against an attack? Malware, spam emails that are held from our inboxes by different filtering and technologies to protect email. Now we've reached the threat intelligence analysis phase. This is achieved via a series of inferences, such as selection, classification, abstraction, decomposition. I think I already mentioned specification, but maybe not. A comparison, matching, instantiation, correlation, and of course, transformation of data. If the information generated by analysis provides sufficient understanding for mitigating a harmful event, then it can be termed intelligence. But if the information that's generated from the analysis doesn't actually mitigate or stop a harmful event, then I think it doesn't qualify as being called information intelligence or threat intelligence. Machines, of course, typically perform simpler, high-volume tasks that reduce a huge amount of input data down to some more manageable subsets with a lower signal-to-noise ratio. Human analysts then apply a critical level of judgment to this filtered data to ensure the final intelligence product contains a minimum number of false positives, like calling, the cat a cat, the dog a dog, and the duck a duck. Object detection, for machine learning and image recognition tools and algorithms, they can be fooled, right? I think we already talked about this in the previous lecture. Adversarial AI, right, where you're using your training data and your understanding of the training data to convince, some type of, object identification algorithm that this is not a dog, right? That this is maybe a cat. They can be fooled, and that's certainly part of InfoSec's world as well. What else? Analysis. You may have heard this before. There's your known knowns. Then you have your unknown knowns. And you have a third area called your unknown unknowns. So let's break this down, because this was an Alan Rumsfeld Pentagon quote, if I remember correctly, when he talked about your unknown unknowns. Let's start with the easy one, known knowns. So these are threats that are previously encountered and recognized by means of identifying similar characteristics. Unknown knowns, these are threats that are known about but have never been seen before, or have been previously seen but are not recognized now because of altered characteristics. But you can still tell what the threat is, even though it was a novel instance of it, right? So that's your unknown knowns. And then finally, you have this last category of unknown unknowns. These are threats that have not been previously encountered, not been previously detected, and using supervised learning and unsupervised learning for AI and ML, you may eventually move them out of the unknown category and into a known or an unknown known category. But anyway, so the last one is the most difficult, of course. What are the unknown unknowns in our links, in our infrastructure? Risks, the unknown unknowns, the ones that the bad guys seem to find, fairly regularly, and then we have to go and react to it and find ways to mitigate that risk and that threat. Like, for example, I think some of the tactics and techniques that were used in SolarWinds by the Russians, were fairly known. I don't think they were unknown unknowns, but they were definitely, patient, using, flying below the radar in terms of their waiting 2 weeks, for example, before the infrastructure that had been backdoored and compromised would beacon out to other command and control to find out what to do next. And they named processes that looked like other processes that might be running, and they had lots of hyper-local infrastructure rather than hosting it in risky geographies under their control. In Russia, they were hosting things here in the US directly, often within a few network hops of the targets that they were compromising. Let's see, and now dissemination. The dissemination phase, reports are delivered to the consumers of threat intelligence efforts. Recipients of intelligence reports will be located at strategic, operational, and tactical levels inside of business functions, primarily risk and security teams. And of course, the technology functions, right? This is primarily the operations team. Suitably summarized intelligence reports also go to, of course, senior executives. Shown here, I think, is a James Bond, briefing laptop from one of the Daniel Craig Bond films, if I remember correctly. All right, threat intelligence, some more information to share about the dissemination phase. You definitely want to have the right content delivered in the right presentation at the right time. The above criteria, of course, is fairly highly interconnected. The best intelligence in the world will be useless if it can't be understood or if it arrives too late. Good quality intelligence and threat intelligence must provide sufficient understanding to allow consumers to mitigate a harmful event. Intelligence must be concise. It must be understandable, as in jargon-free, and actually matching the language and lexicon of the recipients or the consumers of that intelligence. And of course, it has to strike the right balance between narrative, tables, numbers, graphics, and multimedia. So that's what we mean by the right presentation. And of course, intelligence must be disseminated within a time frame that actually enables its consumers to make effective and proactive decisions. What good is an intelligence briefing that arrives late? And in this case, I have a perfect example of an intelligence feed and that arrived late. Short messages, detailed reports, threat feeds, secure portals. These are different dissemination techniques and channels. Each of these has advantages and disadvantages. Customized threat intelligence reports in a narrative format are much easier for business people to understand. On the other hand, it can be difficult to translate these reports quickly and easily into a format that machines can read and factor into the tasks that they execute. So shown here is, I believe, the telegram that went on December 7th, 1941. All ships present at Hawaiian area, air raid on Pearl Harbor. This is no drill. And so obviously this showing up late is a problem, right? People not seeing it and having the context. But this is definitely a short message. It was labeled urgent. And of course, the funny thing, if you've heard the story, is that the Japanese consulate in Washington was prepared to explain that they were preparing an attack on Pearl Harbor, and that they were actually left waiting in the lobby of the Department of Defense, I guess, or the Congress, I'm not sure who. Their whole plan to communicate this and have it be an unannounced, attack was, mistaken. There was a faulty assumption that they would get the audience, that they needed, right? The right time, the right audience, the right message to deliver this. And so this was the first that anyone had learned of it. And it should have been, I think it was probably maybe even a day or the same day of morning of earlier. Anyway, lots of history and war buffs would probably provide more context and information than I on that event and some of the things that went wrong. Let's see what else. And then, of course, there's a review phase, right? So after we do the dissemination and you disseminate the threat intelligence in these different formats to people to get the information, you need to review it. So time to review the success or failure of the operation, right? The threat intelligence operation and mission is used to help gauge the overall customer satisfaction and, of course, gauge the utility of the threat intelligence that was gathered. The key question, therefore, is whether the intelligence product provided sufficient understanding for mitigating a harmful event. So in this case, it looks like we've got a gun inside of a briefcase, right? And I'm guessing that this item on the left is a cassette tape player. It looks like there's 2 speakers, right, on each end. It's kind of angled, and then you have your play head, devices. It looks like there's some tennis balls or squash balls, maybe 4 of them. So I'm guessing it's not tennis. And of course, there's maybe a racket ball racket in there, hairbrush, and other items. Of course, deodorant. It looks like a can of aerosol there, and of course this gun. And if people don't recognize, the gun form and shape, obviously you haven't mitigated the harmful event, right? So you can have all of the threat intelligence and techniques and tools in place, and it can still fail. Of course, in the review phase, there's something that is worth mentioning called confirmation bias, right? Which is a phenomena where analysts actively seek out and assign more weight to evidence that confirms their hypothesis, and they actually ignore evidence that could actually refute the hypothesis. So we must try to avoid confirmation bias when we ask data questions, right? We don't want to sort of lead ourselves down the line and just look for things that only confirm and observations that only confirm our hypothesis. Analysts display this cognitive bias when they gather or remember information selectively, or when they interpret it in a biased way. They also tend to interpret ambiguous evidence as supporting their existing position. And so this results in statistical errors that can in turn lead to flawed intelligence. And of course, here's a lovely little comic that I found that captured this. It's important to remember that correlation does not imply causation. Besides, we all know it was Brian. And so that's an example of confirmation bias in a humorous fashion. Let's see, next up, tactical, operational, and strategic. 3 different types of threat intelligence. There are 3 overarching types. Threat intelligence sharing is often occurring at the tactical and operational levels, but not as much at the strategic level. Threat intelligence includes a strong dose of humanities in addition to computer science, in order to include things like economics and psychology and risk-reward models. And so shown here is a frame from the 1983 movie War Games, showing Whopper, which was War Operation Plan Response. And if you remember the film, this is the simulation computer that was figuring out how to wage successful global thermonuclear war. And if you haven't seen the film, I highly recommend watching it. It stands up even to this day, even though the computer technology has advanced much more since then. A lot of the same things are still true that were true in that film about hackers and hacking. And maybe it wasn't as cute as Matthew Broderick, using a dial-up modem to, find, new game companies in California by using war dialing and just trying one phone number after the other to see if there was a computer on the other end. But anyway, I digress. So let's talk about these 3 types of threat intelligence. So tactical. This is technical intelligence. It includes indicators of compromise, IOCs, such as IP addresses, file names, or hashes, and it's used in the identification of threat actors. So what are the pieces in the game? To use a checkers analogy, who's red and who's black, right? Or other colors if there's other threat actors and other IOCs. Has the piece been kinged, right? Is it a double stack piece? Operational intelligence, details of the motivation or capabilities of threat actors, including their tools, techniques, and procedures. So in this case, what are the configurations of the checkers pieces on the board at the moment? Or on your area of the board, right? Let's say you only operate in the lower right-hand corner of this board and there's no threat actors running around, no reds, no blacks, or other colors. Of course, your industry could be different parts of this board. Chinese checkers might actually be a better analogy here, since it's not just one or two entities at work on the board at any given time. So multiple threat actors are playing out their moves and making operational advances. And then lastly, strategic, right? Intelligence about the overarching risks associated with cyber threats, which can be used to drive high-level organizational strategy. So now we need to be thinking several moves in advance, right? And the simple act of taking or jumping a piece in checkers is much more complicated by the movement rules for various kinds of chess pieces, right? Versus the more simple rules for checkers. We can also introduce the idea of three-dimensional chess tactics and strategies to help illustrate this point, as you might have seen in Star Trek, I think, is the one that showed three-dimensional chess. And so that's when you're really starting to understand, the complexities of threat intelligence and actors in this space. Intelligence sharing, TAXII, STIX, and SIBOX. TAXII stands for Trusted Automated Exchange of Indicator Information. STIX stands for Structured Threat Information Expression, and SIBOX is Cyber Observable Expression. So basically, the Department of Homeland Security's Office of Cybersecurity and Communications, the National Cybersecurity and Communications Integration Center, and US CERT have led efforts to automate and structure operational cybersecurity information sharing techniques across the globe. International in scope and free for public use, TAXII, STIX, and SIBOX are community-driven technical specifications. They're designed to enable automated information sharing for cybersecurity situational awareness, also for real-time network defense, and of course, sophisticated threat analysis. The Homeland Security System Engineering and Development Institute, SEDI, operated by the MITRE Corporation, serves as the moderator of the STIX, TAXII, and SIBOX communities on behalf of the Department of Homeland Security. So let's take a look at TAXII for a second. This is a protocol that's used to exchange cyber threat intelligence, CTI, over HTTPS, hypertext transfer protocol with security enabled. TAXII was specifically designed to support the exchange of CTI represented in STIX. And of course, support for exchanging STIX 2.1 content is mandatory to implement. However, TAXII can also be used to share data in other formats. And it is important to note that STIX and TAXII are independent standards. The structures and serializations of STIX do not rely on any specific transport mechanism. And TAXII can be used to transport non-STIX data. So what does that mean? In this case, you talk about collection and channels. So a collection is an interface to a logical repository of CTI objects provided by a TAXII server that allows a producer to host a set of CTI data that can be requested by consumers. And the consumers are TAXII clients and servers that exchange information in a request-response model. Channels, on the other hand, are maintained by a TAXII server. A channel allows producers to push data to many consumers and consumers to receive data from many producers. TAXII clients exchange information with other TAXII clients in a pub-sub model, right? Publish and subscribe. STIX. STIX is a language and a serialization format used to exchange cyber threat intelligence, again, CTI. STIX enables organizations to share CTI with one another in a consistent and machine-readable manner, allowing security communities to better understand what computer-based attacks they are most likely to see and to anticipate and or respond to those attacks faster and more effectively. STIX has two main components, namely STIX data objects, SDOs, which contain the parameters describing any intel, and STIX relationship objects, SROs, which help establish the relationships between various SDOs and their parameters. STIX domain objects, right? This is a list of them. I don't need to name them all. but a couple of them, of course, are attack pattern, campaign, course of action, identity, malware analysis, tool, vulnerability. STIX 2.1 actually defines 18 STIX domain objects, SDOs. And so when you talk about relationship objects, right? Relationship is a linked object, and a citing is an instance of when that object was seen. So STIX 2.1 defines two STIX relationship objects: the relationship link between two SDOs or SCOs in order to describe how they relate to each other. What was the SCO? I have to double check real quick. Anyway, let's see. Citing denotes the belief that something in CTI, maybe an indicator, a malware, a tool, a threat actor, etc., was seen. External relationships, which represent using an SRO, are used whenever third parties might want to add to the relationship and to express an independent confidence assertion on the relationship. Remember, because these are all assertions of truth, we don't know for sure. Attribution is very hard to do in cyberspace and in cyber warfare, because oftentimes there's a lot of misdirection involved. People will intentionally leave behind snippets of Chinese language or references to different cultural norms within code and comments to make it seem like it's the Koreans or make it seem like it's the Chinese, when really it might be the Russians or it could be the Israelis, right? Anyway, so there's lots of obfuscation and misdirection going on. So that's why that's expressed in this kind of, confidence levels, right, of assertions of relationships. For example, the relationship between an indicator and a malware object is represented as an external relationship that you might want only to be sure to a medium degree of confidence that the indicator is effective in detecting that malware without false negatives. And so where was the SCO? I can't remember. Maybe I don't have it here. But anyway, so these are just ways of representing some of the STIX relationships, because you have an indicator and it could indicate types of certain malware or attack patterns, could have other indicators attached to it that says, well, we think this is the campaign, of Hafnium, for example, the APT-10, I think, out of China that was exploiting zero-day vulnerabilities on Microsoft Exchange servers this month or last month. And of course, lots of other threat actors joined in on the fun, but the first ones that were going around and compromising them and leaving behind web shells on these Exchange Outlook web servers were coming with fairly high confidence from a Chinese threat actor. Another STIX relationship example. So embedded relationships represented using a property in an object with the ID of another object. These are used when the relationship is a fact about the object. For example, the producer that created an indicator, that's not up for debate, right? It's definitely from a particular producer, and they know that they created the SDO. Similarly, the contents of a report are what they are. If later on it's determined that the report should have different contents, it can be updated by the original producer. But applying confidence or allowing third parties to arbitrarily add new objects to an existing report, that just doesn't make sense. And then in terms of SciBox, this is a standardized schema for events or stateful properties, and it's been integrated actually into STIX 2, so you may not see SciBox anymore. But SciBox was a standard schema for the specification, capture, characterization, and communication of events or stateful properties that are observable in all system and network operations. During the design and development of STIX 2, the CTI technical committee concluded that due to the tightly coupled nature of STIX and the SciBox language, that SciBox should just be merged into STIX. So these objects are now characterized as cyber observable objects within STIX and are defined in sections 3 and 4 of the STIX specification. All right, so that was a mouthful. Let me take a pause quick before I talk about ISACs. All right, so ISACs, Information Sharing and Analysis Centers. These are member-driven organizations which collaborate with each other via the National Council of ISACs. ISACs are member-driven organizations delivering all hazards, threat, and mitigation information to asset owners and operators. There are various sector-based ISACs, and they collaborate with each other, of course, through the National Council of ISACs. Formed in 2003, the NCI, the National Council of ISACs, today comprises 25 or more organizations. It's a coordinating body designed to maximize information flow across the private sector, critical infrastructure, and with government. So here are some of the national ISACs. Automotive ISAC, aviation ISAC, communication ISAC, downstream natural gas, very specific, not upstream or midstream, electricity ISAC, FS ISAC, which is the financial services ISAC. There's a health ISAC and an IT ISAC. Security Scorecard joined the IT ISAC recently, so now I'm a member of the IT ISAC, and I have access to a Slack channel with the other members, and we share information as IT professionals doing security. But there's also like a mining and minerals ISAC, which is used by people in the mining and minerals industry, for example, because some of their risks and concerns are different than the ones that might be approached or seen in financial services. And anyway, the ISAC model is amazing, right? Because it puts together a whole bunch of birds of a feather, and we get to have conversations and summits and meetings, briefing reports and papers. And usually it's a paid membership to help maintain the organization and to provide research and services, and sometimes to purchase tools and to use those tools and to make them available to the membership. And that's what Security Scorecard's been doing. We've been providing our platform to the ISACs at a discount or for free for some of them to begin with, so that they can learn how to use the OS int that comes from us scanning the internet every week, so that they don't have to, and to understand their third-party risk, as well as scoring themselves and understanding their own attack surface. So let's see, let's go through a couple of these. The IT ISAC is a little bit different. It's formed by members in the information technology sector as a unique and specialized forum for managing risks into their corporations and to IT infrastructure. Founded in the year 2000 and achieving operational capability in 2001, the IT ISAC is a nonprofit limited liability corporation formed by members of the information technology sector to manage risk to corporations and infrastructure. The IT ISAC provides a trusted forum for experts from the world's leading technology companies to collaborate to defend their enterprises. The IT ISAC leverages a threat intelligence platform that enables automated sharing and threat analysis. And through this platform, members have access to tens of thousands of threat indicators per week. No discussion of threat intelligence would be complete if I did not mention US CERT. And there's the various aspects that come from US CERT. Oh, wait, I think I hit 2. Yeah, US CERT. United States Computer Emergency Readiness Team. It was formed in 2003 to protect the internet infrastructure of the US. The United States Computer Emergency Readiness Team is an organization within the Department of Homeland Security and the Infrastructure Security Agency, right? You've all heard of CISA by now, I'm sure, right? Cybersecurity and Infrastructure Security Agency. They rebranded essentially from a much longer and less fun to pronounce acronym. Specifically, US CERT is a branch of the Office of Cybersecurity and Communications, National Cybersecurity and Communications Integration Center, right? The NCCIC. US CERT is responsible for analyzing and reducing cyber threats and for analyzing and reducing vulnerabilities. And of course, for disseminating cyber threat warning information and coordinating incident response activities. The division brings advanced network and digital media analysis expertise to bear on malicious activity targeting the networks within the United States and abroad. DHS's cybersecurity division created US CERT in September of 2003 to protect the internet infrastructure of the US by coordinating defense against and responding to attacks. These are some of the aspects of US CERT. They are dealing with, like I said, threat analysis, with digital analytics, operations, and operationalizing computer emergency response. Of course, there's a huge communications aspects to the organization and outreach to international. So these are the 5 operational aspects which enable US CERT to meet its objectives of improving the nation's cybersecurity posture, coordinating cyber information sharing, and proactively managing cyber risks while protecting the constitutional rights of Americans. US CERT. So for example, some of their threat analysis involved in reviewing, researching, vetting, and documenting all computer network defense attributes, which is abbreviated as CND, computer network defense, both classified and unclassified events. It helps promote improved mitigation resources, essentially, of federal departments and agencies across the Einstein network, although it failed horribly at even knowing about or thinking that there was something going on, like the SolarWinds attack by Russia. So it's not perfect, of course. And let's see, by requesting, Einstein network by requesting deployment of countermeasures in response to credible cyber threats. So this aspect of US CERT conducts technical analysis on data provided from partners and constituents and monitoring systems to understand the nature of the attacks and the threats and the vulnerabilities, as well as to develop tips, indicators, warnings, and actionable information to further US CERT's computer network defense mission. It should be noted, however, that based on previous incident response efforts, US CERT assesses that many incidents are not detected due to a lack of sufficient detection or logging capabilities. And so this came from a 2013 report, for example, this particular graph that I showed here. Not everyone is actually playing, or recording and logging everything that they should. And so that causes a, lack of observability, of course, in threat intelligence. The analytics aspect, this is the digital forensic examinations and artifact analysis. So this particular aspect, they conduct digital forensic examinations and malware artifact analysis, reverse engineering of malware, for example, to determine attack vectors and mitigation techniques. They also are responsible for identifying possible threats based on analysis of malicious code and digital media, and provide indicators to mitigate and prevent future intrusions. And of course, US CERT has this operations function. It informs the CND, the computer network defense community, on potential threats. So this aspect of US CERT informs on threats, which allows for the hardening of cyber defenses, as well as developing near real-time rapid response community products. In this case, papers and reports, but hopefully those are consumed and used to help put people all on the same page. CISA certainly has their executive reports and activities quite recently. We can expect to see a lot more CISA and US CERT activities in the coming weeks and months of 2021, I'm sure. And then lastly, there's the communications aspect. No, I think we're already talking about, operations, now communications. This supports information development, right? Sharing and maintaining collaboration tools like Stix and Taxi. This aspect, they have a web presence, for example, and it's responsible for establishing and maintaining assured communications, development of dissemination information products, supporting the development and maintenance of collaboration tools. Here, it does feel a little bit sometimes like, two tin cans with a string in between them. If you look back at, what happened in the 2016 election and compromise of election infrastructure by the Russians and disinformation campaign, we did not really have a very coordinated communication plan, right? The FBI didn't even know who to call, right? Because of the decentralized nature of the state election directorates. It varies from state to state. And there's so many different people. And so 2016 actually gave birth and rise to improved communication and tracking techniques. So much so that they distributed a whole bunch of multi-factor auth and tokens, for example, for the election infrastructure across all 50 states or 56 states and territories. And I think we were successful, right? I don't think that there was as much meddling. There was certainly disinformation going on again. But to my knowledge, the election was protected from the actual tampering and hacking of the election infrastructure in 2020 by CISA and other actors. To help make sure that. But, while we were so worried about election tampering, a whole corporate espionage plan through, APT 29 was successful at running for months, almost a year or more undetected. That was until FireEye saw found out what happened to them, and that there was a backdoor inside of their monitoring software from SolarWinds. All right, and the final aspect, the fifth aspect of US CERT is the international, right? So partnering with foreign governments and other CERTs in other geographies. It supports bilateral engagements from CERT to CERT, information sharing, because there's all sorts of data privacy and data lineage and provenance concerns that have to be dealt with. When you share threat intelligence, it can kind of give away how it was captured or gathered, and so that can sometimes be considered sensitive. People don't want to lose their sources, right? If you can infer the source of the information based on the fact that someone has it, they know there was a bug in that room, or that this server and this network or this dark web forum is being monitored, for example. And then let's see, lastly, but not to put it down too much, the CERT is not to be confused with US CERT. So CERT Coordination Center. This is the Software Engineering Institute Computer Emergency Response Team. It's a nonprofit US research and development center. So the CERT Coordination Center, just CERT, is essentially the Software Engineering Institute's nonprofit, the SEI, the Software Engineering Institutes from Carnegie Mellon University, which federally funds Research and Development Center. It is federally funded. It researches software bugs that impact software and internet security. It publishes research and information on its findings, and it works with business and government to improve security of software and the internet as a whole. So the first organization of its kind, CERT, was created in Pittsburgh in November of 1988 at DARPA's direction. Remember DARPA being the Defense Advanced Research and Projects Agency, which actually invented the internet back in the 60s or even 50s, I think, as a packet switch network that could survive, a nuclear attack. So that's why there's no central, control of the internet. It was built to be designed. And let's see. It was founded in 1988 in response to the Morris worm incident. So one of the first worms, computer worms, went up and out, and we realized that we didn't really have a coordination center for people to share information about this and help have a shared defense technique and communication platform. So CERT and US CERT, they're related, but they're two organizations with distinct entities, identities. So here we are. I think it's 5:37. So I made it through the 107 double lecture slides, and we have some time to look at InfoSec in the news. So let me do that real quick. Let me pause the share for a second, though, because I think I need to clean up some information on my desktop before I share it. And what else? I can maybe. All right, maybe if we do a little bit of command prompt stuff, that will be interesting as well. All right, so now I can resume the share. I hope I didn't pause the recording a long time ago, because then there's no lecture for the rest of the class. Gosh, I hope that didn't happen. I'll have to double check actually later. Anyway, so we'll see you next week, and thanks for joining those that were here in real time. And we'll head into the final projects, and I'll get caught up and finish on grading. And good luck, with your other exams and final exams for other classes. All right, see you next week.